Okay, now let's get into the I'm just giving some rough diagram. So it should enter here. It will enter with a speed v1 and it will leave here. So everywhere the magnetic field here is into the plane. So this is the C, A, B. So this should be the radius of circular path. R. So what should be strictly what is R? R should be equal to mv1 by qb. Mass here is given, charge given, magnetic field B also given. So this distance should be equal to how much? This should be equal to R. And we know the side length AC, no? Total AC. So this total length should be equal to 4 minus R. So this should be the perpendicular. So take this is say some theta. Can you find out the theta? So do we know this angle? Anybody? This angle?
So that is also theta.
No, that okay. There's a theta. How much theta? Theta, that one.
Tan inverse 4/3.
53 degrees. Okay, now we know theta. Okay, this. So shall we take help of this triangle O A B C D? So cos theta is equal to. Let me do calculation for this here only. So cos theta is equal to OD by OC. OD is what? R. And OC is what? 4 minus R. So I know cos, this will be cos theta. This will be 3 by 5. R minus 4R. So I'll get R equal to 1.5 meter. That I'll substitute here. And we know what is R. R is equal to mv1 by qb. So 1.5. Mass of the particle 1. Velocity v1. Charge of the particle 1 coulomb. Magnetic field is how much? 2. So v1 should be equal to 3 meter per second. You'll get plenty of numericals where some simple geometry will be involved. Okay, this is about the V naught. Okay, no, V1, no, it is. Now come for a second. In previous question, if particle enters perpendicular with velocity 48 in magnetic region, then how much of time will it spend in a magnetic region? Now look at earlier 3. Now when I give velocity 48, what do you expect? It's going to describe circular path of larger radius, no? Instead of 1.5 meter, definitely the radius will be large. If the radius is large, where the center O will come, will not be on the line AC. So where do that O now will shift? Will shift above C. Try to analyze here only. If it enters with 3 meter per second, the center of the circular path is at O. At O, that one. So as I increase the speed, definitely what happens, the O will shift, no? So definitely 48 is telling. 48 meter means definitely what happens, it should be above C. So now we'll trace the to the next part of the problem. Completed this, I'll scroll down. Now come for this. So here it will be So the center of the arc will be somewhere here. So there's the point C, this A, this is B. So the curved path, some rough diagram is what I can plot it here. After leaving circular path, I don't think so. It should be a curved one. Take like this. So afterwards it will be a straight line. We are not bothered. Once it leaves, we are not bothered. So look at the now the overall thing. So this will be the, so even this should also be the radius, no? So what is that AD, path AD? Will it be a circle? Yes, it's a part of circle. I think already we made a rule, no? This is theta. We know it's a 53 degrees. Now, what is very simple analysis? What is the simple analysis? Is it OA is equal to OD? It may not appear from diagram, but practically it should be no, because that is the radius of circular path. So what is OA equal to? OA should be equal to OD, that should be equal to the new radius. So let me call this is R2. Here it has entered with a speed. So OA equal to OD. So this value of R2. So value of R2 equal to how much? MV by MV2 by QB. So we know mass V2, all that one. So we'll get the radius R2. After getting that radius R2, so what is the time spent? At t equals 0, it is here. At t equals 0. After some time t, it will leave. Or this is TAD. For that, we need this displacement, no? This angular displacement. So this is 53 degrees. Let me take help of some basic mathematics. So this is 90. This will be 37. And we know this distance is 4 meter. Not needed. Keep it like this. That angle phi is what needed. That's all, nothing. So what can be this angle? -37 phi. Apply sine rule. So what all we know? And this distance is what you call ABD, call E something. So we know radius R, so we know OD. We know OD on one side, and next another thing is, so what we needed, that angle phi is needed. So do we have anything about the OC can we calculate? So with that open, I can go for sine rule, that one. So how to determine that value of OC? So I'll write it. So there should be OA minus CA. Yeah, that's all. No, OC is what? OA minus CA. CA value we know, and R2 value we know. So we'll get to OC. So for first, let me write this. Applying sine rule. OC by sine of this should be equal to OD by sine of, what is total angle will be 180 minus 37. Keep it here, no? So what is OC? OC we can write it as OA is equal to CA plus OC. Substitute that and solve, you'll get angle phi. And once you know angle phi, what is omega? Omega equal to pi by the TAD, time taken by that one. And what is omega? BQ by M. It is independent of the speed of projection. Check it now. So something it is given like this: 7 pi by 300. Do calculation later on. Huh? Let me cover other numericals. Different types of strips. All some basic mass will be involved. And what is the one conclusion? What is this? This is an arc. AD is what? AD strictly what you should write. What is AD? AD is a arc or a part of a circle. There's a core idea, you should not get deviated. Whatever be the type of the magnetic strip, the charge particle, if it enters and leaves, it should be part of a circle. Take it for granted, that one. Only if it's helical path, okay, the other situation. So by changing the area, by changing the dimensions of the strip, what will happen? The trajectory there will be there that much only. So you bring it like that. The trajectory will change. It's part of a arc, semicircle, like that will come. But everything should be a part of a circle. The trajectory of a charge particle should be a part of a circle. There's a basic idea.